Welcome to this video on boosting. Now, boosting refers to a family of algorithms that are able to convert weak learners to strong learners. So it kind of again fits into the broad topography of ensemble models. The main principle of boosting, though, is to fit a set of weak learners sequentially in a way that each learner focuses on reducing the errors or rectifying the errors made by its predecessor. Okay, so if you look at this part here, more weight is given to examples that were misclassified by the earlier rounds. The predictions are then combined through a weighted majority vote or a weighted sum, depends on whether you're looking for classification or regression, again similar to aggregation in bagging, to produce the final prediction. Now, the principal difference between the boosting and the committee methods such as bagging is that the base learners are trained in a sequence on a weighted version of data. So automatically you can comprehend that if I have 100 trees to build in random forest, they can all be built independently. So there's some sort of parallelization that is involved. But in boosting, it has to be sequential because the second tree will be dependent on the first tree to complete, produce the errors so that their weightages can be increased. So I'll again get the inputs out of the way, and through running code in the middle, I will highlight some of the nuances that are associated with the different algorithms associated with boosting. So load the iris dataset again, take a decision tree, which is our base learner, and then fit a plot that will give us the different comparisons when using AdaBoost, a specific type of boosting algorithm with n estimators 1, n estimators 2, 3, and 10. Again, as and when I increase the number of estimators, it does a much better job at drawing the decision boundaries on the data. So let us formally fit the AdaBoost algorithm now. We can import the AdaBoost classifier from scikit-learn, divide the data into train and test sets, and fit 10 estimators. Since we saw from the last plot, that's doing better compared to 1, 2, or 3. Now again, if you see, somewhere above 20% is the ideal split, train test split, that we can do in order to achieve a boosting classifier. Okay, so what are the different types of boosting that are available to us? The first that we saw is AdaBoost. Now AdaBoost is an interesting classifier that builds something called stumps. A stump is a special type of decision tree that focuses on building a decision tree that has only 2 legs. So there will be no further depth associated with AdaBoost classifiers. That's the feature. They build only stumps. So this is, again, just to reiterate, a special type of decision tree that is only restricted to level 1. It won't build further or split further beyond this. And that's how you get a weak learner. Fit a bunch of weak learners on different subsets of the data, or rather in this case, fit a bunch of weak learners one after the other, adding more weightage to the errors caused by its predecessor, and you can finally come up with an AdaBoost model. Now gradient boosting models, GBMs for short, gradient boosting models on the other hand, can build full-blown decision trees, and you have much fine-grained control over the parameters that have to be used, which is again something very similar to random forest that we've seen before. And then finally there is XGBoost, which sort of controls and reduces more overfitting through a learning parameter and an eta parameter. And then finally, it's kind of, you can assume, the state of the art when it comes to boosting. Now, installing XGBoost and running XGBoost is again a fairly trivial task that we'll leave as an exercise. We'll supply some study materials and provide an assignment so that you can directly work on this rather than hearing it from me. The overall idea is you now have a solid foundation to bagging and boosting, because we went through in great details what a decision tree is, and once you know that, you just have to understand what the overarching philosophy of ensemble techniques are. And then once that is done, we've covered bagging, and then finally there was boosting that was left. Now you may hear some other variants of boosting again, like GBM, CatBoost. It's still kind of evolving and new techniques are coming up as we speak. It's not hard to be on top of any of them once you understand the fundamentals. So I hope you had a good time learning the boosting technique. Thank you.